Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is minimum pushes of type to type word part 2. Okay, so you will be having a telephone keypad, and each key on this keypad is mapped to some lower English case. Not each key, some keys are mapped to lower English case letters, and the mappings are such that the collection of letters to which a particular key is mapped to are distinct. Okay, so which can be used to form words by pushing them. Okay, so here for example 2 is mapped to A B C. Okay, so we can form words by pushing 2 3 4 5 6 7 8 and 9. Okay, and we need to push key 1 time to type A and 2 time to type B and 3 time to type C. Okay, so the ordering matters here. So C was the third mapping to 2. Okay, if we go in this direction, left to right, let's try to understand it on the board. So 2 was mapped to A, B and C. So if you want to go to, if you want to type let's say C, then you have to press this 3 times in order to, on the first time you will be here and then finally on C. Okay, so this is what the problem statement was saying here. So you have to press 3 times to get to, or to get C on the screen. Okay, so it is allowed to remap the keys from 2 to 9 to distinct collection of letters. You can also change the mapping also. Let's say this is the default mapping. You can do any mapping of your wish. Okay, but those collections should be distinct. Okay, the keys can be remapped to any amount of letters. Okay, so the let's say 2 can be mapped to entire alphabets from A to Z. Okay, but letter must be mapped to exactly one key. Okay, so it should not happen that by letters it is saying that these characters, okay, alphabets, so these alphabets should be mapped to only one key. It means that it cannot happen that 3 is also having A in it, because otherwise it will look something like this. A is mapped to two things, one is 2 and one is 3. So the mapping here should be 1 to 1. Okay, between the keys and the alphabets. So this is one to many. So instead either you could have mapped it to 2 or 3 but not both. Okay, so that's why it is saying that uh, each letter must be mapped to exactly one key. Okay, you need to find the minimum number of times the keys will be pushed to type the string word. Okay, so you will be given a string word and you have to type that on the screen, and in order to do that you will be using these keys, and you have to tell how many minimum key presses will be required to get the word on the screen, or the to type the word. Okay, so return the minimum number of pushes needed to type the word after remapping of the keys. If you want to remap, you can do so. And an example of mapping of the characters on a telephone keypad is given below, and it is to be noted that the one key, star key, hash key and 0 do not map to any letters. So you will not map to any these to any letters. 1, then star, then this 0 and then this hash, they should not be mapped. So in a way you are having only 8 options. Okay, so 1 2 to 9, only 8 options are with you. You can do any one to one mapping of the characters with these key numbers, just like we did here. So this kind of situation should not occur, otherwise it's fine. Okay, so you can, if you want, map the entire A to Z alphabets to also, but that will for sure not give you the minimum key presses. Okay, for let's say example, if you have to type Z, then you have to type uh, a, a push a 26 times in order to get to Z. So it's not an optimal way of doing it, but anyhow, this is the problem statement. I hope you are able to understand what we have to do, and what we have to return. And before thinking of an approach, let's have a quick discussion of the not quick discussion, let's have a quick look at the constraints also. So according to the constraints, the length of the word that will be given to us to be typed is of order 10 raised to power 5, and each character in this word will be lower English case letters. Okay, so these are the constraints. So let's try to think of an approach how we can solve this particular problem. Okay, so let's take one of these examples so that we can formulate one approach. Let's take the third one. Okay, so let's erase the board and take the example here. So this was the input or the word that was to be typed, that was given to you. So first of all, you would be needing the frequencies, because if you have to type a some number of x number of times, then you will be doing the operation to type a x number of times, and that will be requiring exactly the number of keys it requires to press a single a into the number of occurrences of a. Okay, okay, or you can say key pushes required for single a of and occurrences of a. Okay, so that much number of work or number of pushes you have to do. Okay, so here a was occurring twice, so whatever the amount of pushes was required to get to a single a, it will be twice of that. Okay, so that's why frequency of characters matters here. Okay, so we should be, first observation is that we should be having the frequency of characters in the string. Okay, frequency of characters in string, these are the things that we will be requiring. Okay, so string is this word that will be given to you. Okay, so once you are having that, then what you will do, as I said to you that we will be essentially having 8 choices here from 2 to 9. So the second observation being, from 2 to 9 you will be having 8 choices. Let's change the color here. Okay, and if you want to okay, we will talk that about that in a little while, but this is the second observation. Okay, and what you would be wanting to do is, for the character having there will be some scenarios in which you cannot map all the characters. Okay, because if let's say the number of characters in alphabets from A to Z are 26, but you are having only 8 choices, so there will be for sure some keys if there are more than 26 unique characters present in the given word, which will be having more than one mapping. Okay, for example, two can have A B C. Okay, so this kind of situation will arise at some cases, and let's see how many unique characters we are having in this particular input that we have taken. So A, then B, then C, then D, then E, then F, then G, then H, then I. Okay, so how many of these are there? 1, 2, 3, 4, 5, 6, 7, 8, and 9. You can see we have already exceeded the 8 options that we are having. So one of those keys needed to be mapped to more than one character. So we should be doing that. But the thing here is, the key observation here is that you should be doing the mapping in a greedy way. Okay, greedy mapping. Why we are doing the greedy mapping, and what I mean by greedy mapping is, the character, see, the character having the highest occurrences should be the first one mapped to a particular key. What I mean to say is, let's say for 2 you are mapping h and I. Okay, so in order to get to I, even for a single time, you have to press 2 times. Okay, and that will result into 2 into number of occurrences of I was occurring 6 times. Okay, so 2 into 6 will be 12. Okay, and opposed to that, if let's say we have done the mapping in this way, I and H, then here I's contribution would have been 1 into 6, which will be 6, and H contribution here would have been, this is I's contribution. Okay, and H contribution here would have been, H is requiring only to be typed 2 times, and we should press 2 times to get to H. So the key operation, the operations required to get to H for a single time is 2, and then the number of occurrences of H here are, 2. So 2 into 2, it will be 4. Okay, so you can see that for in total we are spending 10 operations, but here for I alone we were spending 12 operations, or 12 key pushes. So in order to get the minimum pushes, we will be preferring the frequencies which are having preferring the characters which are having higher frequency to be mapped first. Okay, to be given preference first to be mapped to some key. Okay, so greedy mapping, and frequent higher frequency characters will be given first preference. Okay, then once you are clear with all these observations, then it's really a matter of implementing, how well you implement this strategy. And let's try to have a look at the implementation, how we have done it here. Okay, so let's take the code to the board and discuss how things will be implemented. So this is the code for this particular, solving this particular problem. Okay, I hope it's visible enough for you. And let's remove this toolbar also, but I think it should be fine. It's not in the way of us seeing the code. So anyways, let's see how we have implemented this approach. So as I told you, the very first thing that you will be needing will be the character frequencies. So this is the frequency array. Since A to Z there are only 26 characters, so what we have done here is, we are taking relative difference of every character with A. Okay, so A's relative difference with itself will be 0, and Z's relative difference with A will be 25. So from 0 to 25, uh, indices will be sufficient in order to get you to have a character frequency mapping. Okay, so we have smartly taken a 26 size arrays, and the indices are representing the characters. So here the 0th index is representing A, and then your 25th index is representing Z, because we have taken the relative differences. Okay, so relative difference. Okay, this relative difference concept is applied to all of these structures that we will be using. Okay, then there will be one array which is character cost, the amount of pushes it requires to get to a character. Okay, amount of key pushes required to, let's change the color here, get to a particular character. Again, here also we are having the same concept. From 0 to 25 indices, we are mapping those indices to the characters, and we will be storing the cost or the amount of key pushes required. So this is for that, and this is key character mapping count. So it is the count of number of characters a particular key is mapped to. Okay, so one side is key, or number of characters mapped is on another side. Okay, so for example, let's say 2 was mapped to ABC, then its number of characters that 2 would have been mapped to will be 3. Okay, so it's working like that. So key character map count. Okay, and since I already told you that we were having only 8 choices, and those choices being from 2 to 9 only, so in total 8 choices. Okay, which character you are mapping to which key really does not matter here. The only thing that matters is how many characters are mapped to a certain key. Okay, and that will tell us how many pushes we will be required to reach to a certain character. Okay, so let's say while we were mapping C to 2, then already 2 characters were have been already mapped. So in order to get to C, we will be requiring 3 character pushes. Okay, 3 pushes. So, and then as I already told you, then the very next step will be to get the frequency character frequencies populated, and have the frequency of the characters that we will be requiring. Then, as I already told you, higher frequency characters will be given first preference. Okay, higher frequency characters given first preference. Preference in order in a way to map to get mapped to a particular key. Okay, so now we will start the mapping, and along with that we will uh, assess the cost that will be required, or the number of key pushes that will be required to get to a particular character. Okay, so here the character mapping is done, and key pushes calculation. Okay, so what we have done is, first, very first condition is that this character should be part of the word. Okay, so this character should be in the word. Okay, so if its frequency is obviously negative, so I will tell you why we are taken instead of incrementing the number of occurrences, why we are taking it to negative. Because by default this sort function does us increasing order sort. Okay, but in order to get to a decreasing order sort where higher frequencies are getting first in the array, so in order to do that, I have taken uh, the negative approach. Okay, what is the negative approach is, let's take a fresh slide for that. uh, higher the number in its negative magnitude, the more earlier it will be in our array. For example, if there were 6 occurrences of I, so it will be -6, and if there are 7 then 7 occurrences of J, so it will be before I, obviously. Okay, and this negative sign is just for the facilitating to get to this particular ordering. Okay, because this, by default, the nature of this sort is to sort the array in increasing order. Okay, so that's why we have done that. And here the negative frequency indicates that this character is present. Okay, so if this is the case, then we will do the calculations part. For calculations part, you can see that uh, First of all, we have taken two variables. The minimum mapped key, the key which is having right now the minimum mappings to it, will be represented by this minimum mapped key, and the number of mappings to that particular key will be represented by this variable. Okay, initially it is set to maximum integer value because obviously we cannot reach that, so I am taking it as a infinity, you can say. So then we will find the key to which currently minimum characters are mapped, and since we were required to do minimum amount of pushes, that's why we are trying to find a key to which minimum characters are mapped right now. Okay, so once we are having hold of that key, then we will for sure increase the number of characters that will be mapped. For it's the same that if we are trying to map c to a character, uh, C to a key, and all the keys are already having three mappings, but fortunately we find two which was only having two mappings of A and B. Then we will give C a mapping of 2. Okay, so this is what we are doing here, and then we will increase the number of mappings that 2 will be having from 2 to 3. Okay, this is that step. And then what we will be doing is, now we are having two things. The amount of pushes it will be required to us to reach to, or us to get the current character on the screen, and its frequency, the number of times we have to get it on the screen. Okay, so the total cost will be multiplication of those two things. Okay, so this is that formula only, this formula being used. So let's the number of key required to get a character single time and the number of occurrences of that character. Okay, so this is the formula being used here. And -1, as I already told you, for the frequency part we have taken it to a negative side in order to get higher frequency characters first preference of being mapped. So we need to multiply it by -1 in order to get the correct frequency in positive magnitude. Okay, and then yeah, uh, then we will simply take a variable total cost, or the total amount of key push is required. Okay, total key push is required. Then you will simply add up all the things in the cost array and return that. Okay, and I really hope you are able to understand the approach. And before ending the video, let's have a quick discussion about the time and space complexities also. So let's clear the board here. So time complexity wise, it's order of n, and you might be a little confused that we are using some nested loops here. Then why you are saying that it's order of n, and where I mean that this n is the size of the word that is given to you. Okay, so as you can see, it is very much clear that this linear traversal will be running order of n times. Okay, here it's order of n, so let's highlight that. Okay, and for this part, as you can see, it's running constant amount of time. Okay, and if we want to take a upper bound of that time, so it will be order of 26 into 8. Okay, so we can take it to be constant, so it's fixed amount of time, so we can take it to be constant. So that is why. And the second thing is that if you are worried about this loop, this one also will be running order of 26 times only, because these sizes are fixed here. Okay, so you need not to worry about that. So the only thing that is contributing will be this. And if you are saying that frequency sorting will do something, it will also result into constant complexity, because it will be this. Okay, so as you can see, it's a constant thing, so you can take it to be order of 1, and that is why overall the time complexity will be linear. And space complexity wise, you are using 26 size arrays, 26 size arrays and one 8 size array. So space complexity wise, you can say 26 into 2 plus 8. but if you want to take it as a constant, then it is up to you only. But this is what is for the complexity analysis part. Okay. And say other than that, we are not using any extra space, you can see. And these are the complexities. So if you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSS skills. And until next time, keep solving more and more problems, and I will see you in the next video. Thank you for watching.